Welcome, Precalculus students, to week 4 of distance learning. This week we're going to zero in on one idea, and that is how to expand binomials and utilizing the binomial theorem. What you see up here on the board is the notes for this lesson and then the first example. So now let's go ahead and look at the notes for this particular lesson. The first thing that you see on the left side is Pascal's triangle. Now this triangle can go down an infinite number of levels, so for whatever level that you need. For this triangle, you are going to be writing down, starting at the top, 1, and then the second row is going to be 1, 1, and then from there on you're going to be adding together the numbers above to create that new levels number. So for the third row, you have 1, 2, 1, 1, 2, 1. Then the next row, 1, 3, 3, 1, 1, 3, 3, 1. And then the last row written up here is 1, 4, 6, 4, 1. Now this can continue on for an infinite amount of rows so that you could be able to expand an infinite amount of binomials. This will be utilized when we're working through some of these expanding that you see in example 1. So the row represents what the exponent of the binomial would be. So a plus b to the 0 power would be 1. A plus b to the first power would be 1a plus 1b, and so on. So what you see on the right side is a coefficient formula for binomials. So if you were given a binomial to the 25th power and you wanted to figure out what number the third term would have, instead of going down your Pascal's triangle, you could plug it into this formula. The formula is NCR, which is equal to n factorial over n minus r factorial times r factorial. We're going to look at a few examples dealing with this, but keep in mind that if this is a little bit difficult or you're struggling with it, you can always use Pascal's triangle to get the specific coefficient that you need. With that being said, let's look at example 1. For example 1, what we're going to be doing is we're going to be expanding these binomials that you see. So A, B, and C. We're going to be expanding those. So part A. Part A is a plus b to the 8th power. What I like to do is I like to make a row of the coefficients and then make 2 more rows dealing with the first term and then the last term. And let me show you what that looks like in part A. So if you continued your Pascal's triangle to the 8th, what you would end up getting is 1, 8, 28, 56, 70, 56, 28, 8, and 1. Then you would take the first term to the power that you have, so a to the 8th, and then you would go down 1 in your exponent as you write it underneath each one of these numbers. So A7, A6, A5, A4, A3, A2, and A. Then you're going to do the same thing in the third row here with B, but you're going to start from the last term. And then from there, you're just going to combine your column to create each term in this polynomial. So the final answer would be 1a8 plus 8a7b plus 28a6b squared plus 56a5 b to the third plus 70a to the fourth b to the fourth plus 56a to the third b to the fifth plus 28a squared b to the sixth plus 8ab to the seventh plus 1b to the eighth. Now, as large as that answer may seem and the meticulous steps that we went through, it actually is 10 times easier and much less time consuming doing it this way than writing out that parenthesis 8 times, taking 2 and foiling them, taking 2 and foiling them, and going through, and then distributing, and then going through, distribute again, distribute again, distribute again, and going through the math that way. So this saves a ton of time using Pascal's triangle. Part B, 2x plus 3y to the fifth. Same thing as before, except for you're going to notice one thing different from part A to part B, and that is there are numbers with x and y, and we didn't have that in part A. So watch what we're going to do when we write this out. So we're going to use row 5 of Pascal's triangle, or 1, 5, 10, 10, 5, and 1. So that's going to be what you write out in that first row. And then we're going to go in, take the first term to that power, and then go down. So 2x to the fifth, 2x to the fourth, third, to the second, and to the first. And then we're going to take the last term to that exponent power at the last term. So what I wanted us to see here is that when we're given numbers in this binomial for a question, what ends up happening is when you take it to the power, 2x to the fifth power, both of those pieces get taken to that power. So 2 to the fifth power along with x to the fifth power. So in this first term spot, what you're going to have is 32x to the fifth. And then you're going to do the same thing with the next spot. 5 times 2 to the fourth times 3 to get your number. So your final answer when you combine these, 32x to the fifth, 240 x4y, 720 x3y squared, 1080 x2y3, 810 xy4, and then 243 y to the fifth. The number one mistake people make on these is making sure that you multiply the number, like your coefficient number of 5 here, times each one of those numbers below to that power. So 5 times 2 to the fourth power times 3. Or in this case, 10 times 2 squared times 3 to the third. Now that we finished part B, let's go ahead and look at part C. The only thing changing from part B to part C is this time we're going to put in a subtraction. For this example, I wanted to give us a little bit more room, so I went ahead and wrote it off across above it. So 1, 4, 6, 4, 1 is the row that we're going to be using from Pascal's triangle because of the 4 exponent. Then we're going to do the same thing that we've done before, take the first term to that power and then go down by 1 each time. So 2x to the fourth power 2x to the third, 2x to the second, 2x. And do the same thing with the last piece of the binomial. But in this case, make sure that you include the negative with it. The negative goes in that parenthesis with the number. Now we simply multiply down, so 1 times 2x to the fourth. So 1 times 2 to the fourth, x to the fourth, or 16x to the fourth. For the next spot, 4 times 2 to the third, or 8, times negative 3. And then next, 6 times 2 squared, which is 4, times negative 3 squared, which is 9. And then put your x squared, y squared. So your answer is 16x to the fourth minus 96x3y plus 216x squared y squared minus 216xy to the third plus 81y to the fourth. I'm going to give you a chance to write that one down, and what we're going to be doing in the next section of examples is looking at finding specific terms or the coefficient to a specific term. Example 2, find the coefficient to the term that they're asking about. So for part A, it's 2x minus 4y to the fourth power, and they're looking for the second term. So you're looking for just the coefficient number for the second term. Part B is a minus b to the 13th power, and you're looking for the third term. And then part C is 2x plus y to the 5th power, and you're looking for the second term. So for these 3 problems in this example, for the first one, I'm going to be showing you how to complete it using Pascal's triangle. For the second part, I'm going to show you the coefficients in NCR. And then for the third part, I'm going to show you how to use it using Pascal's triangle again. So part A, we are looking at the fourth power. So the row 4 here, 1, 4, 6, 4, 1. Now you would start out calculating it just like we did in example 1, except for you're only going to do one calculation here. You're only going to be looking at the second term. So once you write out all of the steps like we did in the last example, you are only going to zero in on that one spot. So 1, 4, 6, 4, 1, and then 2x to the fourth power, and going down. And then the last term, negative 4y to the fourth power. And then because they're only asking about the second term, this is the only calculation that you're going to do. And they're simply asking for the coefficient. So you're just going to do the numbers that you see here. 4 times 2 to the third times negative 4. So negative 128. That's what you get when you multiply 4 times 2 to the third power, or 8, times negative 4. That's the only number they're asking for in these problems. So you're just finding that coefficient number for that particular term. Part B, a minus b to the 13th power, and you're just looking for the third term. Now, like stated in the very beginning, you can use Pascal's triangle for doing this. So you can go down to the 6, 7, 8, 9, 10, 11, 12, 13, so that you can use those coefficients, or you can use the formula that you see on the right side. I'm going to take you through how to get that formula for this problem. For the formula up here, the n is the exponent, the r is your term minus 1. So in this case, 13C2. 13C2. And that equals 13 factorial over 13 minus 2 factorial times 2 factorial. So if you're trying to calculate 13th factorial, that is 13 times 12, 7, 11 times 10, all the way down. And you also have the ability, if you have your graphing calculator with you, to calculate the NCR right away or calculate a factorial. That'll be located on the Math menu. So go to the Math button on the left side of your calculator, and then you should go over to the probability heading and you should be able to see those there. Since I don't have one available, I'm going to have to do some of this by hand. So watch how I do this. Now what you see is 13 all the way to 1 and 11 all the way to 1 and 2. So what we can cross out is 11 down on the top and on the bottom, and you're left with 13 times 12 over 2 times 1 or 2, which is 156 over 2 or 78. So 78 would be that location in Pascal's triangle if you went down to the level 13 and the third term. And then what we would normally write underneath for going first term to the power and down and last term to the power and down is the first term to what is the 13 minus 2, and then the last term, or negative b, to the r, which is 2. So 78 times negative 1 squared would give us an answer of 78. So no matter the term that you're looking for, the first subtraction here would be what goes to the first term's power. And then the last factorial, the r, would be the last term's power. Now, once you've done this a couple times, this can be a faster route than writing out Pascal's triangle every single time. But if this seems a little bit confusing, you're welcome to do Pascal's triangle every time. Now let's look at the third and final problem to this example. For the third problem to this example, it's 2x plus y to the fifth to the second term. Since it's such a low exponent, let's go ahead and use Pascal's triangle where it's 1, 5, 10, 10, 5, 1. And then take your first term to that power. And the last term to the power. And then we're looking for just the number of the second column here. So the second term. So 5 times 2 to the 4th power. And the answer is 80. That finishes up the last example for this lesson. So now what you're going to see is the assignment posted below. Please ask questions, reply, send a chat, email, whatever you need to do. Please ask questions. I'll be glad to answer any questions that you have. And I'm going to be praying over each and every one of you this week. I hope that you all have a great week, and I hope to see you guys soon.